training. Okay. Does everybody see what I see?
Mm-hmm.
Yeah.
Okay. So this is outcome 3B now that we're starting. We're looking at operations. So think about operations of fractions. We're just going to do it now with rational expressions where there are potential of having some variables in it. So the first two operations we're going to do today are going to be just solely on multiplication. We're going to stick with multiplication and division. They're probably the easier operations moving through this. We'll get into adding and subtracting on Monday, I guess. This is Wednesday already, hey? So this will give you time to kind of work through this, and then we'll focus next week on adding and subtracting and work our way through that. So to get us started, if we think about multiplying fractions together, you have to remember that you're literally just taking your numerator and you're timesing your other numerator. You're timesing your numerators together, and you're going to times your denominators together, right? You do not need a common denominator when you're multiplying fractions, okay? So it's just strictly straight across. You're going to get 20 straight across the bottom, and you're going to get 120, okay? Same thing when we have a fraction, we want to reduce it. We want to try and make it smaller if we can. So you always look at your final answer that you've got, but you're going to see if you can reduce the numerator and denominator. In this case, I could divide both of these top and bottom by 20, and I'm going to get 1 over 6 as a final answer. So when we move into this, looking at with rational expressions, we're still going to do the same thing, okay? You're going to look at your denominators. They're all going to be kind of multiplied together. We might not, because there's some x's and some y's and some binomials in there, we're not necessarily going to just multiply everything together, but we may look at a binomial and just leave them as individual binomials, all showing that we're multiplying them together in the numerator. And then we'll do the same in the denominator. And then we'll just, like we did last day, we basically have one big fraction. We'll end up canceling out what we can. So let's take a look at this. So if we take a look at multiplying rational expressions, we can look at just like what we did from last day. We have an expression, a fraction times another one. Your first step in this is let's always identify what our non-permissible values are. So what pieces won't satisfy? What values would we put in for A here that wouldn't work? Meaning, I don't want to get 0 down in the denominator, right? So that's one thing that we have to address moving forward as well, just to watch for those non-permissible values. The other piece, you're going to want to, when you can, you're going to factor. Is it kind of fuzzy on your end, or is it just on my end?
I'm good. Kind of hear it.
It's kind of fuzzy a little bit.
I know. I'm wondering why that is like that. Okay. Okay. Okay, so if we're looking at factoring, let's go back and let's factor this. I've got a squared minus a minus 12. I need to worry about factoring that. So I'm going to factor that into two binomials. So when I look at this, I go a squared minus, so I need something that multiplies out to a negative 12, and it's got to add up to a negative 1. So those two numbers, I'm hoping you're recognizing that's going to be a minus 4 and a plus 3. On the bottom, so you're basically going to go through, factor what you can in the top and bottom of every single fraction that you've got going on. You've got a squared minus 9. I'm going to factor that as well. So I'm going to go a minus, this is the difference of square. So I'm going to take this as a minus 3 times a minus, or a plus 3, right? Difference of square. You're simply just, you've got two terms, two binomials that will be identical. You take the square root of the first term, square root of the last term, and one's going to be positive, one's going to be negative. So that's that going on. The next one over here, I'm going to factor it as well. So I'm looking in this scenario, I've got a trinomial. It is, I've got to multiply out to a 3. I've got to add up to a negative 4 this time. So it's got to add up to a positive 3, or multiply out to a positive 3. So this is going to be a minus 3, a minus 1. So negative 3 times a negative 1 gives me the positive 3 I need. Negative 3 plus a negative 1 gives me the negative 4 that I need. Okay, so I've got that. Now the bottom piece here, I've got some lovely stuff going on. I've got a squared minus 4a. So in this situation, I think what I'm going to do here is I'm going to take out a greatest common factor. So I can take an a out, which is going to leave me with an a minus 4. How do we feel about that so far? So all I've done is just factored numerators, denominators, right? That's all I've done. I've done nothing else. Okay, once you have factored, now you can address those non-permissible values. So that means I'm going to look down here in my denominators and all of my non-permissibles. So in this case, I'm essentially taking each of your binomials that you've got, or each of your factors that you've got, and you're setting them equal to 0. So this would mean that a couldn't equal a 3. It couldn't equal a negative 3. It couldn't equal a 0. And it couldn't equal a 4. So those are all my, what we would consider non-permissibles, because that would mean I would end up having a 0 in the bottom of these fractions, and that doesn't work, okay? That creates an undefined situation. So remember your non-permissibles. Now your next step, well, if you're just multiplying these fractions, this is just another way of saying, hey, I'm going to take my numerator that I have, and I am essentially going to multiply all those numerators together. So all I've done is multiply them. I'm just showing that I've multiplied them all together in one fraction, right? No different than when I take the 5 times the 4 in my fraction up above. I multiplied them together to give me 20. I'm just not going to actually physically multiply all of these binomials together, because that would just create a nightmare for us, okay? But I'm still showing that they're all being multiplied by the way I've got them wrote. I'm just showing that they're being multiplied. So I rewrite this. That single a, I can put that single a out in front so it doesn't get mixed up in all my binomials and my sets of brackets. Still showing everything is getting multiplied together. Each of these binomials factors are being multiplied. Now, okay, that's great. That's like, we've got this in the scenario of like we had 20 over 120. Now our last step is to reduce. So in this instance, to reduce, you got to take a factor and see if you can divide that same factor out of the denominator. So in this instance, I see an a minus 4 on the top. I also have an a minus 4 on the bottom. I can cancel those out. I've got an a plus 3 in the numerator. I also have 1 in the bottom. They can cancel out because they share between the two of them. I've got an a minus 3 in the numerator. I also have 1 in the denominator. And pretty soon, now I've got an a minus 1. I don't have an a minus 1. So I've got an a minus 1 left in the numerator. And on the denominator, the only thing I have left is that single a. And that's where I leave that particular answer. How does that feel?
Perfect.
Perfect. Okay, so nothing, really, everything, all the steps in here, you've seen before, right? It's just a matter of collecting them, using them for different purposes. That's the only difference, right? So you've done the restrictions before, you are able to factor from before, you know multiplying fractions from before, and what that does. It's just this piece and ensuring, which you did some of this in the last unit a little bit, of simplifying those rational expressions. So we've just kind of put it all together, combined it. Okay. Next one, you've got 4x squared over 3xy times y squared over 8x. So this one looks a little bit different than the last one we did, right? This one had some trinomials and some binomials in it that we were able to factor. These are just single monomials. Monomial divided by a monomial. Monomial divided by a monomial. So in this instance, you're going to kind of come back and treat it like what we did with our basic fraction. Okay, so in this case, I'm going to take my numerators and I'm going to multiply them together. Well, 4x squared times y squared simply gives me 4x squared y squared, okay, if I'm multiplying them all together. And on the bottom, I've got 3xy times 8x. Well, that's given me 3 times 8 gives me the 24. I've got x times x, which is going to give me x squared, and I've got a single y on the bottom. So this 4x squared y squared over 24x squared y is looking like our 20 over 120, right? Like that's, we've multiplied everything together. We've got it like that 20 over 120. Now I just need to simplify, okay? Again, we're at the stage, once we get it to this is like what we were doing in the last outcome. So basically now I'm going to look at my 4 and my 24 and think about how can I reduce that? Well, that's the same as saying 1 over 6, right? 4 divided by 4 gives me 1. 24 divided by 4 is what's going to give me 6. I'm just reducing that fraction. Now I look at the x squared divided by the x squared. Well, that cancels out, right? They're the same factor, x squared over x squared. And then my last piece is I've got y squared over y. Well, that's the same as me just saying I've got y. So in this instance, I've got a 1y over 6, or I can simply just say y over 6. I don't need to put that 1 in there if I don't want to. So that's where I would stay there.
Cool.
Questions? Okay, then let's move on to the next one. The next one looks at, you've got y squared minus 9 over r cubed minus r, and we're timesing this to r squared minus r over y plus 3. Oh, you guys, we didn't do it on this one. What's your non-permissibles here? On your last one.
0.
What
Yeah.
are non-permissibles?
So x can't equal 0, right? Because if I put a 0 in here and multiply these all together, I'm getting 0, right? So same thing with my y. My non-permissible there, y can't be 0 either, because if I put a 0 in here, I multiply all that together, I can't have a 0 in that denominator. So my non-permissibles here will be x can't equal 0 and y can't equal 0. Okay, so the next one. Before you can identify what your non-permissibles are, you have to do any factoring that needs to happen. So let's start with the factoring first. Where am I going to write this? Let's write it underneath. So y squared minus 9, I hope you're seeing that as a difference of square that will factor into y plus 3 and y minus 3. And I am timesing that, or I've got that over, sorry, r cubed minus r. Well, in that instance, I think I hope you see that you can take out an r and you're left with an r squared minus 1. Which, do you guys see that you can reduce this even further? So this r squared minus 1 is like a difference of square. It's going to be r plus 1 and r minus 1, right? Perfect square of r squared, and perfect square of 1 is 1. The square root of 1 is 1. Okay. So now, in your second part, this is multiplying. That's a multiplication. I've got r squared minus r. So same thing. I think I'm going to take out a greatest common factor of r, and that's going to leave me with an r minus 1. On the bottom, I have a y plus 3. Can't factor that. There's nothing to factor there, right? So really down here, what I've got going on is I've got all of these in the numerator have to get multiplied together. So I've got an r times an r minus 1. They're all getting multiplied with the y plus 3 and the y minus 3. And on the bottom here, I'm multiplying all my factors. So the r plus 1 and the r minus 1 and the y plus 3 are all getting multiplied together. Before you do any canceling, take a look at what your non-permissibles are. So I've got some r's down here and I have y's. So I need to know what r can't be. What can r not be?
No idea, I'm doing something here.
So you're taking this r and this factor, these ones, you're setting them all equal to 0 to find out what r can't be, right? So essentially, if I put this r and equal it to 0, I'm saying r can't equal 0. If I take the r plus the 1 and set it equal to 0 to figure it out, I'm going to get, and solve for r, I'm going to get, well, r can't be -1. And in this case, r, if I did r minus 1 is equal to 0 and solve for r, I'm going to get r can't equal 1. So r can't be 0, -1, or a +1. And y, if I did the same thing, I'd be saying y plus 3 equals 0. Well, if I solve for y, I'm going to find out that y can't equal a -3. So if I put a -3 in for y, this is going to come out to 0. If I put a -1 in for r, I'm going to get 0 here. And if I multiply those all together, I'm going to get 0 on the bottom. So those are my non-permissible. I'm only looking at my denominator for my non-permissibles, right?
Yeah.
So now, once you've figured out your non-permissibles, you've multiplied, showed it all being multiplied, now you do any canceling that you can. So in this case, I have a y plus 3 on the top. I also have it on the bottom. So I can cancel those out. I've got an r in the top and 1 in the bottom, so I can cancel those out. I've got an r minus 1 and an r minus 1 that can cancel out. And what I am left with is I've got an a y minus 3 on the top, and I've got an r plus 1 on the bottom. And that is my resulting answer. And that's, you're going to get where your fractions or what you've got for an answer left are going to be a rational expression. You're not going to get it down to an exact number by any means. Okay, so you're always the potential of having some variables in there. Sometimes everything will cancel out. So question for you, if everything cancels out, what do you have? Like, what would you write as an answer?
1.
Yeah, you would have a resulting answer of 1, right? If you were able to cancel everything out of the numerator and everything out of the denominator, you would have a resulting answer of 1. Absolutely. Okay, questions on multiplying?
Nope.
It's pretty straightforward.
Yeah.
Okay, let's look at dividing. So dividing now, you got to go back to thinking about fractions. So if I had 5/3 and I'm dividing it by 1/6. Well, if I'm taking two fractions and I'm dividing them, you have to remember that you're basically going to take and multiply by the reciprocal of the second fraction, right? So if I look at 5/3 and I divide by 1/6, what I'm doing is taking 5/3 and I am timesing by 6/1, right? I'm going to take the reciprocal of that second fraction so that I can multiply these fractions together, which in theory then, I'm back to doing exactly what I did with the multiplying. I'm going to multiply my numerators together, which is going to give me 30, multiply my denominators together, which is going to give me 3, reduce, in this case, is going to give me 10. Okay, so that's what we would do normally with just the basic fractions without any variables in it. We use that same process now to use for our rational expression. So let's try a couple of these. So you've got x squared minus 4 And this is, we're dividing here. And we're going to divide by x squared minus 4x. And then the other fraction that we're dividing out is x squared plus x minus 6 over x squared plus x minus 20. My suggestion with doing these is probably right off the bat, do your factoring like you normally would. And then you just got to remember that you're going to have to take the reciprocal in here, right, of that second one. So sometimes some of you might feel like, hey, I'm going to do that reciprocal first so that I don't forget. Just, you got to remember that you're going to have to take the reciprocal of that, okay? Oh, and we're also asked to identify any of our non-permissibles. So in order to identify any non-permissibles, we need to factor as well. So why don't we just start this process with factoring first? So if I look at x squared minus 4, x squared minus 4 is, I'm hoping you see, I'm going to write it actually underneath here. That's a difference of square. So it's going to factor into x plus 2, x minus 2. And on the bottom, I'm going to have x squared minus 4x. Well, this one here isn't a difference of square because we've got this x that's attached with a 4. So what I would suggest here with that one is let's do a greatest common factor. So pull out an x, which is going to leave you with an x minus 4 there instead. And then in my second rational, I've got x squared plus x minus 6. Same thing, I need something that multiplies out to a negative 6, adds up to a positive 1, which should be x plus 3, x minus 2. And in the bottom, I need something that multiplies out to a negative 20, adds up to a positive 1. So in that case, I think we're going to go x plus 5, x minus 4. Okay, so those are just your basic, your factoring again, like what we've been working on. Okay, so now it says we have to identify all non-permissibles. Okay, so non-permissibles again. Look at your factoring or your denominator. So in my factoring, I'm looking at an x. Well, x can't equal 0. And if I look at this one, if I set that equal to 0, I'd say that x can equal 4. It's essentially the opposite sign that you're seeing in here, right? If I come over here, x can't equal a negative 5, and x can't equal a positive 4, which I already have that. Here's the kicker with this. You're dividing by this fraction. So watch what happens now. So now if I go ahead and if I'm truly dividing, then that means I'm going to take that second rational expression and these are going to flip, right? So really I am multiplying by an x plus 5 times an x minus 4 in the numerator, and I've got an x plus 3 and an x minus 2 in the denominator. So I've just taken this rational expression here and took the reciprocal of it. But look, now look what's in your denominator. I've got an x plus 3 and an x minus 2. So I talked about non-permissible values of just being these ones that we did before we flipped it. We also have to take into consideration that second rational expression that we flip. The numerator also has to come into part here for our non-permissibles. So this x plus 3, that means we also have a non-permissible of minus 3 and a non-permissible of a positive 2. So we have to take into consideration when we're looking at non-permissibles, we take both the numerator and denominator of that second rational expression because it gets flipped and that numerator ends up in the denominator as well. Okay, so we definitely need to take that into consideration. Okay, so now that we've got these and we're multiplying these, technically these are all getting multiplied together in the numerator and these are all in the denominator. Once you've got it to that stage, you're back to canceling out what you can. So you go across an x plus 2. I don't have any x plus 2s. I've got an x minus 2, both top and bottom, so I'm going to cancel them out. I've got an x minus 4, top and bottom. I'm going to cancel those out. And then once I've canceled that out, then I'm just simply going to rewrite the pieces that didn't get canceled out. And that will end up being my resulting answer. How does that seem?
Good.
Once you get the division piece and take the reciprocal of that, you're back to just a basic multiplication now, right? Like that whole same process, it stays the same. So essentially you'd be doing the same in the next question. If we go through that one, same thing, I'm going to factor, factor, factor. This is really going to make sure you get your factoring down.
Fun.
And that you're solid in that and understanding of that, hey? We've got that. I've got a difference of square, so that's going to be m minus 7, m plus 7. And I'm still going to leave it as division for now, just until I get everything factored. So it's got to multiply out to 7, add up to a positive 8. That's going to be an m plus 7 and an m plus 1. And on the bottom, in this instance, again, I think I'm going to use greatest common factor here, which means I'm going to take an m out, and I'm left with an m plus 7. So in order to do, if I'm doing my non-permissibles of this, again, I'm looking at my denominators. So I look at my denominator here. This would be an m can't equal a positive 7. M can't equal a negative 7. And I have m can't equal 0. And again, I have an m can't equal a negative 7. Okay, I don't need to rewrite it twice. I've already accounted for it. But take note, you're dividing here with this rational expression. So also check the numerator. So I can't have m as a negative 7. So again, I had that already. But the one I didn't have is I need to include m can't equal a negative 1. I have to make sure I include that in there. Now at this point, now you're dividing, so you're going to do the same thing. You got to take the reciprocal of that second rational function and rewrite. So numerators are all going to get multiplied together, which is going to be that m is getting in there and the m plus 7. And on the bottom, I've got m minus 7, m plus 7. I'm just writing it all under one rational expression when I flip that. The biggest thing is just keeping track of the second part of this is just this last rational expression flipped, right? And now you're at the stage of cancel what you can. So m minus 7s, that can cancel out. I've got an m plus a 1 that can cancel out. I've got an m plus a 7 can cancel out. And I am left with an m and an m plus 7 as my remaining pieces that didn't cancel out.
Well, that was fun.
That was fun. It's kind of like, feels satisfying to cancel things out and cross them off the top and the bottom. Okay, the last example I want to do with you guys today is a combination, right? So you've got some dividing happening and you've got some multiplication happening. So I kind of want to go through this one with you just to, same thing, you're still going to have to account for the factoring, you still have to account for your non-permissible, all of those pieces, but it's just pulling both division and multiplication together in this one. So first off, factor away. So in this case, I am going to factor 3x plus 12. You're going to use a greatest common factor in here. So you're going to pull out a 4. or 3, and you're left with x plus 4. Oh, we left the best for last, you guys. Okay, so you've got a 3x squared minus a 5x minus a 12. So this one, because you're dealing with a value in front of your x squared, and it's looking like I can't pull a 3, I can't take a greatest common factor of 3 out of this, I'm going to get into the scenario where I'm going to have to factor this by either box method or airplane method, right? So if I think of this, I've got to say, hey, I've got to find something that multiplies out to give me 3 times the 12, which is going to give me negative 36. Got to add up to negative 5. So 2 numbers that multiply to negative 36, but add up to negative 5. I think you're going to have to work with 9 and 4 on this one, right? And I think your 9 is going to have to be negative. So in this instance, I'm just going to work with this off to the side and then I can put my answer back up in my question. But I'm going to look at this airplane method. I'm going to put 3's in my first of my terms and a 3 on the bottom because that's my first term, the A value. And now I'm going to plunk in my minus 9 and my plus 4 in here. And then I've got to just simplify this so I can get it into my 2 binomials that I can go and stick back up here in my question. So in this case, I'm going to take a 3 out of this first binomial. I'm going to factor that out. Nothing can come out of the second binomial, and I'm over 3. So now my 3's cancel out. So my 2 binomials that I'm going to plug up back here are going to be x minus 3 and 3x plus 4. And I'm just going to write divide. And then my next rational expression I look at, I've got a 12. Well, I'm not factoring anything out of 12. I'm just going to leave 12 as is. There's nothing I can do with that one. I look at the 3x plus 4. Same thing. There's no greatest common factor that I can take out of that, so I'm going to leave it as is. So you're going to get some of that. You're going to get a combination, right? Some of them you can factor, some of them you can't. Then the last one, I've got 2x minus 6. That I can factor. I can take a 2 out, and I am left with an x minus 3. And on the bottom, I've got an x plus 4. Can't do anything with that, so I'm just going to leave that one as is. So now that I've factored, let's think about non-permissibles. So if I'm looking at non-permissible values, I'm saying that I'm only looking at my denominators, except where I have division, then I'm going to have to look at top and bottom. So I'm saying here, x can't equal 3. Ooh, and then this one. So if I take 3x plus 4 and set it equal to 0, I'm going to subtract 4, which would give me 3x is equal to negative 4, and divide both sides by 3. I'm getting x is equal to negative 4/3. So I've got x can't equal a negative 4/3 as one of my non-permissibles. And that 3x plus 4 shows up again. So I don't have to write it again. I've just got it here. And I've got x plus 4, so I've got x can't equal a negative 4. Now the only other piece, because I'm dividing this whole rational expression, I would look also to the top in the numerator of that fraction, which has just a 12. There's no variables there. So I really have no non-permissible that I have to worry about there. So then really this I don't have to look at, I can just disregard that. So these are my only non-permissibles. X can equal 3, negative 4/3, and negative 4. So, which brings me back to now, once I've done all the factoring, identified my non-permissibles, now I can just, let's clean this up, let's get this and cancel out what we can. But before we can cancel, you've got to take the reciprocal of the second rational expression because we're dividing it. So that means I'm going to put the 3 times the x plus 4 from my first one. If this gets flipped, this 3x plus 4 moves up to the top, and I've still got a 2 times an x minus 3. That's all in my numerator. And in the denominator, I've got an x minus 3, a 3x plus 4, and an x plus 4. Oh, and I almost forgot, this 12 is coming down, right? So I'm just going to throw that 12 out front for now. Doesn't matter where I put it. Sometimes our whole numbers, we usually just try to put them out front. Same with this 2. I could really look at this. It could get multiplied to this 3 that's already out here. Eventually it's going to get multiplied, okay? So first off, look to see if there's anything that can cancel out here. So I've got x plus 4s can cancel out. My 3x plus 4 can cancel out. My x minus 3s can cancel out. Ooh, we got rid of a lot of stuff out of this one. So now I've got a 3 times a 2. That gives me a 6. And I've got my 12 on the bottom. 6 12, I can reduce that to 1/2. And that is my final answer. And that one, actually, you guys, we got rid of all of our x's, our variables out of it and got it down to an actual value in that one. That doesn't happen very often.
Wow.
Yeah. How was that?
Good.
Not
Seem
bad.
okay? Yeah, the multiplying and dividing isn't so bad. That seems to be the okay piece to this. What I think I might do, I'll see if I can get to it. I'll post it on our Google Classroom. I might put a Google Forms of just rational expression, simplifying, multiplying, dividing piece up until this point. I might post something on Friday just for you guys to play around with and try it if you like, just to see where you're at and know how it's going, okay? And then Monday, what we'll do is we'll meet back and at 1 o'clock again, and we will focus on the adding and subtracting rational expressions, kind of work through those then. So you remember with adding and subtracting fractions, you need a common denominator. Well, you're gonna need that for this as well, right? So we're gonna have to play around with what that looks like moving forward, so.
Cool.
You guys have questions?
Nope. I'm gonna go have a shower.
No, I think we're smooth sailing here.
You're good, you're good?
Yeah, Frito, I think we're looking amazing, hey?
No, I think we're ships just floating here.
Oh boy, you guys.
Up, bro.
Nope.
Hello.
Oh, Frito.
So, if you guys don't have any other questions,